Platonism, especially in the context of science, refers to a philosophical view rooted in the ideas of the ancient Greek philosopher Plato. In science, Platonism generally emphasizes the existence of abstract, non-experimental entities, such as mathematical objects, that exist independently of our ideas and the physical world. Here is an explanation of Platonism in science, the basics of Platonism in philosophy. Platonism is based on the idea that there is a world of immaterial, eternal, abstract forms or ideas. These forms are the true reality, and the physical world we perceive is merely an imperfect reflection of this higher reality. For example, a circle drawn on paper is merely an imperfect representation of the abstract, ideal concept of a circle that exists in Plato's world. 2. Platonism in mathematics. Platonism in mathematics is the belief that mathematical entities, such as numbers, sets, and shapes, exist independently of human minds. According to this view, for the existence of abstract, mathematical objects are discovered, not invented. They exist in an immaterial world that is not affected by time or space. Objective facts. The facts of mathematics are objective and do not depend on human beliefs or experiences. For example, the truth of the Pythagorean theorem remains true regardless of whether or not anyone has discovered it. Epistemology. Humans can access this world of mathematical facts through reasoning and intuition, not through sensory experience. Therefore, mathematicians discover these facts, just as a scientist might discover facts about the physical world. 3. Platonism in physics and other sciences. While Platonism is directly related to mathematics, some scientists and philosophers extend Platonic thinking to other sciences, especially physics. In this context, abstract structures. Theories and laws of physics can be thought of as describing abstract structures that exist independently of the physical world, similar to mathematical objects. For example, the laws of physics can be thought of as ideals for describing the shapes that govern the behavior of matter and energy. Symmetry and beauty. Many scientists find that theories that are elegant or mathematically symmetrical are more likely to be true. This reflects a kind of Platonic belief that the universe contains an underlying abstract order that is more real than the chaotic empirical reality we observe. Idealism. The use of ideal models, such as frictionless planes or point masses, in physics can be considered a form of Platonism, as these ideals represent abstract, idealized forms that phenomena in the real world only approximate. 4. Criticism of Platonism in science. Despite its influence, Platonism in science is not without its critics. Empiricism. Opponents argue that science should be based strictly on empirical evidence and observation, rather than on belief in non-empirical entities. They argue that all scientific concepts must be rooted in the physical world and subject to observation and experimentation. Nominalism. Some philosophers advocate nominalism, which denies the existence of abstract entities. Nominalists argue that what we think of as abstract entities are merely convenient fictions or shorthand for describing patterns in the physical world. Epistemological concerns. Critics also question how humans can have knowledge of these abstract entities if they exist outside of space and time, and therefore cannot be directly observed or interacted with. 5. Influence on scientific methodology and philosophy. Platonism has influenced how some scientists and philosophers approach the search for knowledge. Theory selection. The preference for theories that display mathematical beauty or simplicity can be seen as a Platonic influence, suggesting that these qualities are hints at deeper, more abstract truths. Scientific realism. Platonism is compatible with scientific realism, the belief that scientific theories aim to describe a reality that exists independently of human thought. This contrasts with anti-realist positions, which suggest that scientific theories are merely useful tools or constructs that do not necessarily reflect objective reality. 6. Modern interpretations and applications. In contemporary philosophy of science, some interpretations of quantum mechanics, cosmology, and fundamental physics bear traces of Platonism. For example, Max Tegmark's mathematical universe hypothesis posits that the universe itself is a mathematical structure, reflecting a deeply Platonic view of reality. Abstract Platonism in science posits a world of perfect abstract forms that underlie the imperfect empirical world we observe. In mathematics, this suggests that numbers and mathematical facts exist independently of humans.